All right, guys, we are back again dealing with conditional statements. This, again, is how you can win an argument or know better how to argue. So it deals sort of with hypothetical statements or statements that are contingent on something else. So this is the study of if-then statements and their truth value. So a statement is not necessarily true. As many of you know, you can make a statement and it can be completely malarkey. So let's look at this. So a conditional statement is in the if-then form, just like if P, then Q, because P is contained inside of Q. So our hypothesis section would be if something. So if something happens. So if it is P, and then the conclusion or the resulting statement is the Q, or what else you know. So because P is inside of Q, we know if P, then Q, but that doesn't really make sense because we don't know what P and Q are. So here's an example that does make sense. If you are a man, then you are a human, because man falls under the larger title of human. So Venn diagrams are a good way to represent our conditional statements. First thing we want to be able to do is identify the hypothesis statement and the conclusion. The hypothesis always follows the if, and the conclusion always follows the then. So if we have if an animal is a robin, then the animal is a bird, that makes my hypothesis the animal is a robin, and my conclusion, the animal is a bird. So pause the video and think about, in all three of these statements, what would be your hypothesis and what would be your conclusion. So pause the video now. I'm going to come back with everything highlighted. Should not have been very difficult here. Everything following an if is your hypothesis statement. Everything following your then is the conclusion. So now we're into problem 2, dealing with writing conditionals based off something that we know. So we know that vertical angles have to share a vertex. A reminder of what vertical angles look like is if you had two lines crossing, the angles directly opposite each other, those are your verticals. So this angle up here would be vertical with this angle down here, and they share this vertex. So you identify the hypothesis and the conclusion. So the conclusion is that they have to share a vertex if they're vertical. So your if-then statement, pause the video and try to write this. So our hypothesis is that they are vertical angles. Our conclusion is they will then share a vertex. So we say if two angles are vertical, then they share a vertex. Go ahead and pause the video to deal with the got it. But I already pretty much gave you the answer here. Try these practice problems right here. So here we have kind of an algebraic if-then statement. So up here we see that our hypothesis is that 3x minus 7 equals 14. Our conclusion is that 3x equals 21. We could actually take this a step further and solve for x, but we're not asked to here. So if this equation is true, then this equation is also true, because all we did was add 7 to both sides. So we know that this to be true, and that would be my if-then statement, or my conditional statement. So think about the conditional statement for number 4, pause the video, come back for the answer. All right, so what we see here is if something is a wheat, then it is a grain, because our hypothesis is always the smaller circle and our conclusion is always the bigger circle of the Venn diagram. So the truth value of a conditional statement is that it will either be true or false, and to prove that something is false, you only need one counterexample. So that's the biggest thing that people don't understand, is if I can prove you wrong once, then that means that you are not right, and therefore it is not a true statement. So if we look down here at finding the truth value of these statements, now in A, you might need to know a little bit about cultures or geography. So it says, if a woman is Hungarian, then she is European. Well, to check that, we look for a counterexample of a Hungarian woman that would not be European. But the thing about that is, Hungary is a European nation. So all Hungarians are European. So if she's Hungarian, then she is European, and this holds true. So think about number B. If a number is divisible by 3, then it is odd. So to prove a counterexample of that, you would want to find an odd number that is not divisible by 3. Actually, I said that backwards. We want to find a number that's divisible by 3 that is not odd. However, if you find either of those situations, we know that this is not true. So if I think of numbers divisible by 3, my first easy number that I realize is 6. 6 is divisible by 3, and it is not odd. So 12, 6, I mean, any of these larger numbers, there's a ton that are divisible by 3, but yet not odd. So this is false. So here's one of my favorite conditional statements. If a month has 28 days, then it is February. So we see our hypothesis here is if a month has 28 days, our conclusion is then it must be February. So classify whether this is true or false based on can you find something that satisfies the hypothesis that does not satisfy the conclusion. So pause the video and think about this. Hopefully you did not fall into the trap. If a month has 28 days, well, here's the funny thing. Every month has 28 days. So this is false. So then think about B. If two angles form a linear pair, they are supplementary. When we think about B, we see two angles that form a linear pair. Well, we have to remember what a linear pair means. This means that they would pair up to make a straight line. And then we have to remember what supplementary means. Well, supplementary angles are an angle pair that will add up to 180 degrees. So that is true. Any two angles that form a linear pair have to then be supplementary. So this statement comes out, in fact, to be true. Think about 5 and 6 here. Try those on your own for a moment. Pause the video, then come back for the answer. So again, we're looking for counter examples. So our hypothesis here is that you live in a country that borders the United States, and our conclusion is that you must live in Canada. So in order to prove this true, you have to not find a counterexample. If you find one counterexample, you prove this false. So think about, is there a counterexample to this situation? So when we think about number 5, the easiest counterexample that I can think of is that Mexico borders the US and Mexico is not Canada, so therefore my statement is false. Then we see if an angle measures 80 degrees, then it is acute. This may have gotten chopped off of your notes page, but think about it. 80-degree angle, then it's acute. Acute just means that it's an angle less than 90 degrees. So is 80 degrees less than 90? Yes, I think no matter what, 80 degrees is less than 90. So this statement is in fact true. So if you're now in problem 4 of the Pearson module, one thing you need to look at here is up in these menus, right where the note is pinned up. That's our key concept menu, and that will show us some really important information here. This table right here, which is also in your notes, it goes over the conditional, the converse, the inverse, and the contrapositive. So I'm going to pull up my little table, which shows it a bit easier. So what we're talking about is the negation of a statement. So when we have a statement P, the negation is the opposite. And we write it with a little squiggly line, means the negation of P or not P. So any statement, you can just add a not in front of it. So the sky is blue, the sky is not blue would be the negation. So we then look at the 3 related statements that every conditional statement has. Now for right now, don't try to be very analytical about what's true and what's false. You just want to understand how we would write these. So if my conditional statement is that I have a measure of angle A is 15, then angle A must be acute. Now this conditional statement is true. A 15-degree angle is acute. The converse just flips the location of the hypothesis and the conclusion. So my if is then followed by the conclusion statement, angle A is acute, then is followed by the original hypothesis statement, measure of angle A is 15. So this can be written Q then P, or if Q then P is how we'd read it. The inverse of this original statement is the inverse of P and the inverse of Q. So notice, if measure of angle A is not 15, then measure of angle A is not acute. And yes, you're immediately thinking, but there's examples where it's not 15 and it is acute. I understand that, just hang on. And the contrapositive is essentially the inverse of the converse. So we negate both the hypothesis and the conclusion, and it's flipped around. So if A is not acute, then measure of angle A is not 15 degrees. And we read that if not Q, then not P. So then we have a little table here that tells you about the truth statements. So truth values of the related statements. So here is going to make sense of the table above that I told you not to worry about. So our conditional statement, if our conditional is true, then the converse and the inverse are false, but the contrapositive will be true. So this is something to try to remember. If the conditional is true, then the contrapositive is true, which again, that was the inverse of the converse. So think about it. If the converse is false and the inverse is false, then the opposite of a false statement will be a true statement. And you have this problem in Pearson, but let's go ahead and walk through it together. If we look at the hypothesis and the conclusion, our hypothesis is if the figure is a square, our conclusion is the figure is then a quadrilateral. So to write the converse of that, again, we switch the hypothesis and the conclusion. So now we have if the figure is a quadrilateral, then it is a square, which again, we know the converse is not true. This can be true, but it doesn't have to be true. Then we write a counterexample that shows us that it's not true. So a quadrilateral that's not a square, well, a rectangle is the easiest quadrilateral that's not a square. So then we write the inverse, so we negate both the hypothesis and then the conclusion. So if a figure is not a square, then it is not a quadrilateral. So again, we write the reason why that's false, our counterexample. So here are not squares that are quadrilaterals. And then we write the contrapositive and want to show that that's true. So remember, it's the inverse of the converse. So if the figure is not a quadrilateral, then the figure is not a square. So this contrapositive is true because in order to be a square, it first has to be a quadrilateral. So if we're not a quadrilateral, we are not a square. Now, you do not have to know all about nutrition or vegetables to be able to write these statements. So here I begin with if a vegetable is a carrot, then it contains beta-carotene. So the converse of that statement, pause the video and try to write it on your own. The converse becomes if a vegetable contains beta-carotene, then it is a carrot because remember we just flip the hypothesis and the conclusion. The inverse leaves my hypothesis and conclusion in that order but makes them both opposites. So if a vegetable is not a carrot, then it does not contain beta-carotene. And then the contrapositive is the inverse of the converse. So you take the converse and negate both of these statements. So if a vegetable does not contain beta-carotene, then it is not a carrot. So I actually like this in the algebraic form better. So go ahead, take a moment and try to write out the conditional, the converse, the inverse, and the contrapositive for both of these. So you see here we have the converse, we flipped around the hypothesis and the conclusion. We have the inverse, and then we have the contrapositive, the inverse of the converse. And those all actually are true. So now we look at number 8, the pianists are musicians. So if a person is a musician, then they are a pianist, which is not true. There's lots of musicians that are not pianists. If a person is not a pianist, then they are not a musician. Well, again, that's not true. And if a person is not a musician, then they are not a pianist. Then that is true. You'd have to be a musician to be able to play piano. So you have this Venn diagram here in your notes, and you want to practice writing conditional statements, 3 separate conditional statements, all based off of this Venn diagram. So pause the video and give that a shot. When we write these conditional statements out, we can say if you're a pitcher, then you're a baseball player, or if you're a pitcher, you're an athlete, because pitchers is contained inside of athletes. And then we can also say if you're a baseball player, you're an athlete, because baseball players are inside of athletes. Venn diagram circle as well. So we first here have to write the converse of the statement, and then if the converse is true, we write true, and if not, we want to provide a counterexample. So I'm just going to go through all these verbally because I'm running out of time. So the converse of this, we would flip the order around. So if the absolute value of x is 6, then x must be -6. Well, this you should immediately see is false because absolute value of x could be 6 when x is +6. In 24, if y is negative, then negative y, or the opposite of y, is positive. Well, that is in fact true because if negative y or if the opposite of y is positive, then y must be negative. And really quickly, here are your answers for the converses of these. The counterexample here, if x squared is greater than 0, then x must be less than 0. You should be able to find a value that satisfies here. Please make sure that you let me know if you have any questions, comments, or concerns, and do your homework.